Section 3.3 Measures of Central Tendency and Dispersion from Grouped Data. In this section, we'll look at these three objectives. Objective 1, we want to approximate the mean of a variable from grouped data. We've discussed how to compute descriptive statistics from raw data, but often the only available data have already been summarized in frequency distributions or grouped data, so we don't have the raw data in that case. And although we cannot find exact values of the mean or standard deviation without the raw data, we can approximate these measures using the techniques discussed in this section. So let's look at how to approximate the mean of a variable from a frequency distribution. For the population mean, we take the sum of our data values times the frequency divided by the sum of the frequencies. And we have a similar formula for the sample mean, where the x sub I is the midpoint, or the value of the ith class. F sub I is the frequency of the ith class, and n is the number of classes. So let's look at an example. Here, the National Survey of Student Engagement is a survey that, among other things, asked first-year students at liberal arts colleges how much time they spend preparing for class each week. The results from the 2007 survey are summarized below. We want to approximate the mean number of hours spent preparing for class each week. So first, let's list this vertically. And we see we have the time and the frequency in our first two columns. Remember that x sub I is the midpoint of our class. So we take the time and we take the midpoint between 1 and 5. So we would add 1 plus 5 and divide by 2 to get the 3 there. Same thing with the next one. We take 6 plus 10 and divide by 2 to get our 8, and so forth. Then we'll take each of these values for x sub I and multiply them by the frequency value. So we're taking now our frequency column and multiplying it by the x sub I. And we'll sum our frequency column here, and then we sum our last column where we have multiplied our median by the frequency. So remember our formula for our sample mean, we're going to take the sum of the median multiplied by the frequency, and we're going to divide that by the sum of all of the frequencies. So you take the sum of this last column, the 14,250, and we're going to divide that by the 1,000, which was our sum from our frequency column. And we see that we get then a value of about 14.25. Objective 2, we want to compute the weighted mean. The weighted mean, x bar with a subscript of w, of a variable is found by multiplying each value of the variable by its corresponding weight. Then we add these products and divide the sum by the sum of the weights. So we see the formula here for finding that. W is the weight of our observation, and x sub I is the value of that observation. In this example, Bob goes to the By the Way nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate-covered peanuts, and 1.5 pounds of cashews. The raisins cost $1.25 per pound. The chocolate-covered peanuts cost $3.25 per pound, and the cashews cost $5.40 per pound. What is the cost per pound of this mix? So to find our weighted mean, we're going to take the weight of our observation. So the first one we had our pound of raisins, so we had 1 pound, and we'll multiply that then by the value, which was $1.25. Then we're going to add that to the weight of the next observation, which was 2 pounds for our chocolate-covered peanuts, and they cost $3.25 per pound. Plus, now we had 1.5 pounds for cashews, which cost $5.40 per pound. And we'll divide that then by the sum of the weights, which was 1 pound plus 2 pounds plus 1.5 pounds. So you see that when we work at the top, we'll get a total of $15.85, and divided by, in the bottom, 4.5. And this will work out to be approximately $3.52 per pound for the mix. So that's how we would compute a weighted mean. Objective 3, we want to approximate the standard deviation of a variable from grouped data. To do this, we'll look at a formula for the population standard deviation and also for the sample standard deviation. Notice we're using the same symbols, sigma for population standard deviation and S for the sample standard deviation. In these formulas, x sub I is the midpoint or the value of the ith class, same as it was for our mean from group data, and f sub I is the frequency of the ith class. Here we have an algebraically equivalent formula for the population standard deviation, sort of like our computational formula we used in the last section. So let's look at an example. We're going back to our National Survey of Student Engagement. So we see we have the same data. And here now we want to approximate the standard deviation number of hours spent preparing for class each week, whereas before we found the mean. So we have a similar table. We have the time and frequency. And x sub I is still the median value from the time column. So remember, we added the two values and divided by 2. So the 3 came at 1 plus 5 divided by 2, gave us our 3. Our next column, we take our x sub I and we subtract the sample mean. And remember, this mean we calculated in our first example when we found it to be 14.25. So we're taking each of the values in our x sub I and subtracting the 14.25 to give us the values in this column. And in our last column, we'll square those and multiply them by the frequency value. And at the bottom here, we've summed the frequencies and summed our last column. So remember that the sample standard deviation was equal to the square root of the sum of our last column here, the x sub I, minus the mean squared times the frequency, over the sum of the frequencies minus 1. So we have, under our square root sign, we have 65,687.5 divided by 1,000 minus 1. So we see that under the square root sign, we'll get a value of 65.8 approximately. And when we take the square root, we'll get about 8.1 hours. And this would be our standard deviation for the number of hours spent preparing for class each week. So let's look at how we could find that using our calculator in our technology step by step. So the first step, we enter the class midpoints in list 1 and the frequency or relative frequency in list 2. So we press Stat and hit Enter on Edit, and we'll enter our class midpoints. Then in list 2, we arrow over and we want to list the frequencies there. Once we have both values in the list, the next step is to press Stat, highlight the Calculate menu, and we'll select one variable stats. Now, before you press Enter, it's important to pause for a second. With the one variable stats appearing on the home screen, we'll now press Second, which is the orange key, and then the number 1, and we see that we have a L1 appearing on the screen. Then we press the comma, which is right above the number 7, and then we press Second and the number 2, which gives us an L2 on the home screen. So the home screen should have the following: one variable stats, list 1, comma, list 2. We press Enter to obtain the mean and the standard deviation. And notice at the top, x bar was the mean we found in the first example, 14.25, and our SX is our sample standard deviation for our group data, which was 8.1 approximately.